Hi everyone. We are waiting a bit. You are not in the frame. Please come here. Please no. It's been so slow. Okay. Sorry for this delay. We are really slow, and half of our team can connect. They were supposed to talk instead of me right now, but I think I will do it. Oh, okay. Anyway, we are Ultimate Robotics team. In this frame, you see half of our team. Another half, I hope, will be joining us very soon. We are working on various open source devices, mostly medical ones, but not exclusively. Well, medical not in the sense like they're medically certified for any clinical use, but in a sense they are providing some data useful for medical perspective. Well, our most developed project is uECG. You see a lot of them on my hand right now and on Olga's hand in EMG mode, but initially uECG was an ECG device, and one of them is on me right now, and I hope you can see. Maybe yes, if you can show the screen to the camera. Where I have problems with screen sharing, but right now on me there is a sensor here. It blinks with heartbeats. Okay, thank you. And well, this project is our most developed one. It can be it can be actually used in practice, but we are working on it further. And for a long time, we wanted to make a device for muscle sensing. And while we are working on a specialized device that has more channels and is better suited for this task, we also adapted uECG to measure muscle activity. So you can see here, if I'm depending on which fingers I'm activating, they change color. Maybe you will see on the device, it's on your hand, it's better. You can see better. Oh. Okay, and well, I probably will talk about our way to this state. We started in 2012, and it was well, we know basically nothing about hardware back then, and it was 2 people. Oh, sorry. I see that our team, another half of our team cannot connect yet. Sorry, one moment. Okay, we will try to resolve it, and meanwhile, I will try to do what was planned in a bit different way, but anyway. Okay, back then in 2012, we started to, our name Ultimate Robotics came from that time because we wanted to work on robotics. And we started with quadricopter, hexapod, and wheeled robots, some large stuff. It was interesting, we learned a lot, but also as we moved on, we've seen that not only technology, I mean practical use of technology available to people is not ready for this yet, it also
Hi. Finally, it was a very stressful situation because we're two parts and one part connected and the Zoom couldn't understand what's happening, and Dmitry and Olga, they were very stressed too. So please just continue what you were saying. We're very sorry for this. I mean, we couldn't. There were no buttons. I guess Zoom didn't expect this, or maybe.
Yes, please continue now.
Please continue. We really want to hear you. And yeah.
Okay. It's great that you connected, guys. It's I really wasn't prepared for this turn of events.
Yeah, I understand. So we had a different plan. Please continue. You're doing great.
Yeah, you are.
Okay, where I was, 2012, and we started making large robots, and didn't really succeed with them. Well, we learned a lot, and we did some of them. They worked, they were moving, but they were nowhere close to what we wanted to see. We wanted to see some very cool stuff being made by us at that point, and it wasn't really great because we lacked everything. All electronics was too large, too bulky, too unreliable. Mechanics was even worse, and we decided that we cannot really make mechanics at home yet, but we can make electronics better. And we moved into that direction. We started to make, first of all, we started to produce PCBs at factory. It's a huge step actually from manual production. And we started to make them smaller and learn new technologies, new stuff, started to use better chips. And we worked a lot as freelancers, did, basically, I think, back then we did a lot of various sensing. For example, this is quite a remarkable project in my hand. I will show it to you in a bit more detail. It is ultra-wideband radio. Okay, I will show it again because I'm not sure it was there. Here. Yes, it's based on DVM 1000 module. It is basically system that measures how long radio signal takes to travel between two such modules with very good precision. So it allows to measure distance because we know the speed of the light and we know time, so we know distance, and it allows to localize objects in space quite well. Back then, there were no solutions that were available to make a community in this area, and we designed this system from scratch. It took us probably 2 years to reach good results with it. And after all, it was interesting, but also very complicated, and we were not sure how to move it further, how to make it more accessible, and it was quite expensive because of the price of these modules. And so it's we shelved it, and maybe since then we used this approach in several other projects just a bit, but never went too far with the system. Also, yes, as experiments, not experiments, commercial projects on which we learned, we did, well, we started with very common prototypes like this connection of several breadboards, well, not breadboards, but stuff intended for breadboards. Then we transformed this stuff into modules like this on a single PCB after the prototyping stage was done. And we were measuring various fitness parameters or sports parameters like speed of motion, angular speed, repetitions, number of repetitions, how many times you did certain exercise, and so on. And we did several such projects. Some of them were really challenging because many sensors had to interact with very low latency. And we even made our own device intended for placing it on your feet while running. It should have told you the shape of your run, how good you are placing your feet on the ground. Maybe you are doing it not exactly the right way, so it was supposed to tell you that. But we were a bit stuck on the software side, and while it worked on a low level, it also wasn't converted into something useful. Then we worked a lot on a prosthetic hand. We tried to make a prosthetic hand that is open source and available. And while we tried to do both mechanics and sensing part, we concentrated on sensors. And our goal was to use, back then our goal was to use not gel electrodes like are on uECG, but contactless electrodes like this device. This device has a sensing area on the bottom side of the PCB, which should go on a skin, but it doesn't need to, first of all, it doesn't have to be put exactly on the skin. It can work through fabric. And also it was supposed to be more robust. Unfortunately, we implemented it and it worked. We were able to get a reasonably good signal from the system, from muscles, from heart, and to a lesser extent from brain. But we realized that it's very sensitive to noise, and we cannot actually use it in practice for prosthetics. Unfortunately, because it was a very interesting idea. But we made a prototype of an EEG headset. Not sure. It's in a disassembled state right now, so it's not really clear how it is supposed to work. But it well, basically this yeah. I don't think we can put it right now. It's not in the right shape, but it is supposed to be put on a head, and has this 8-channel sensing board and a set of active contactless electrodes. We assembled it once, and it got a signal from it. But realize that it's very sensitive to the quality of this contact. So it's all those active electrodes must be positioned really well and pressed to your hair in a very consistent way to get any useful signal. So we basically were stuck at mechanical side of this project. We do hope to return to it one day, hopefully one day soon, but not today. And yes, this was our path previous to uECG. And when we were doing all this stuff, we realized that we want to make something that can be used in practice. And so we took the very basic thing. ECG signal is maybe the easiest signal of a human body to measure and to process. And we made this set of devices. I will show the one which I'm wearing right now because it is open in terms of enclosure. So this is
Without case.
Yes, I can even take it out further. So on the bottom side there is nothing. All components are placed on the top side. I probably can even unglue the battery. Yeah. It's like most of our projects is based on NRF52 chip, which allows to send data via radio, and some analog part. We used precision amplifier, generic ADC, some hardware filtering, some filtering on the firmware side of the device. And well, it works quite good. You can really get signals that can be practically used with it, and you can adapt it for other needs, like this EMG, which is a substitute for a good, smaller, more specialized EMG system, but still it works in a quite educative way, I'd say. So you really can see these muscles activating in real time with the same electronics and very similar firmware. Firmware for EMG mode requires just a couple pages of code in addition to the main system of the uECG.
You have few comments
Yeah.
from Sandy Roberts.
I see.
You can answer something.
Okay. Anyway, that's almost where we are now. Actually, we have another project I don't have on my side. It is pulse oximeter, which we developed this spring. I believe it's on the other side of our team right now. And we
Actually, can I? Actually, oximeter is on your side.
We just were looking for it. Didn't
Yeah, we just were looking all over it. Okay, maybe look for it. Maybe we can take. I don't see the comment, but maybe we can say something.
Yes, say.
Because we just thought that you were talking about our, how we did stuff before. I don't know if the vertical video will be.
Yeah, it was.
Yeah. Okay, so we just dug up our old box. I just wanted to talk about how we do all of this stuff. Basically, Dmitry was talking about how we wanted to make sensors, but didn't have it. And I'm afraid we were making electronics all of these years. Like, we were really into it, I'm afraid. Like, to the point that we just now, like, for example,
I mean,
I don't know if you...
yeah.
These are just versions of uECG, and they're all been made by us, like on
Manually.
this stuff, yeah, manually on this stuff. And that's like the high-tech version of it, because before we've been making like this, and we've made a lot of those. like, so basically, right now I have here, I think, I'm not sure, but if Olymmetry have oximeter, one of the first versions, I'm not sure if it is this, but I think this was it. Yeah. So and right now it looks better because
Right now,
we discovered factories. We've begun to produce factories, and then right now the new board which you write is this.
it will look like this, but better with components.
Yeah, we just we're going to just bake it soon, but we actually are a bit slow because we've bought a 3D printer. I know that 3D printer is the first thing that people probably buy to make stuff, but for us it's really high tech right now because up to this point, this is probably not normal, but we've been making like these hundreds of boards by hand, like for example, this stuff, the uECG, that is a lot. We've made by hand all of the SMD components we can solder and etc. And we've been like making versions and versions of that. And also, Dmitry was talking about uEMG device. Here is it. It's I think it's 4-channel, and we are going to revive it soon and just make some enclosures for it finally and make some proper wires. And we have ideas how to make the magical wires like really look cool, because right now I don't know the magical wires which people have that are usually like thick like this. I have one of these here, but I think we can make them better. I don't know if we can find some wire as an example. I think we can make them like this. Don't know. It's Teflon audio wires, and if we could make them really small for our EMG device, it would be nice. So back to the printer. I don't know. I think it really comes down to perspective, because we're really deep into electronics, like elbows deep. And we've been baking them, we've been soldering them, and right now we really discovered bulk orders for passive components, and we'll be buying our first reels of capacitors and stuff. And we've recently discovered that Chinese people, they like on the factories, they like when we send them components. And up to this point, we've been ordering this stuff. I don't know, it comes like this. What is it?
Well,
So I'll just show. We're the production part, so we're excited about that. So it comes from the factory like this, assembled stuff with components in these boxes, in these bags, and we have also the second boards like this.
Base station.
The base station. And up to this point, we've been asking workers on the factory like to do everything themselves. Like we send the bomb, they buy components and stuff like this. But I didn't know up to this point that it was not convenient to them, and it was also more expensive. So we've been like digging up the Taobao to find like passive components, and they're really cheap too. So we can basically order them here and then just cut them in pieces, like send them like 600 of capacitors, like a set for producing on devices. And they'll be very glad, and they'll be not have to deal with buying all of the components. So we didn't know that. That's a discovery too.
Just in case anybody watching doesn't know, Taobao is like a Chinese version of Amazon.
Yeah.
It's a big online store for mainland China, and we buy there because we know the ways.
Well, the way is just a Chrome translator, plug-in translate, and you just and you can have a freight forwarder. You basically forward the address in China and you forward it here, because Taobao didn't sell to overseas until now. Maybe they start selling now, but until now we've been sending it to a Chinese address. So what I wanted to say about the printer is really sorry if it's we've bought Enter 3 basically, but we know that people start with the printer, but right now we only have like it's been 2 weeks since we discovered that printers are like really good right now, because we had an old Maker original.
It's still somewhere in the back room.
Yeah, we don't want to talk about it because
My still show it.
Yeah, the axes were a bit bent, I think, and we've been and the heated bed. It was like, well, basically we've tried to print stuff for ECGs on that printer, but it was very bad. And right now we've been like printing a lot. We've been printing on this Ender Creality Ender 3. We've been printing a lot of stuff, and it's been doing really great. And like yesterday, we bought a new PTG filament, and we're going to try it. And we bought random colors, so we're really excited about that.
Yeah, this one.
Yeah, this guy. Bought even a golden filament, I guess, with pretty odd ones here in Ukraine.
Or we just like shiny things.
Yeah,
That's
maybe.
what we do.
So anyway, I guess it really depends on the perspective, because we've been doing a lot of electronics and people usually print a lot of stuff, but we just now got a 3D printer. And we discovered we can make the enclosures for all of the devices. And yesterday we've been designing, it's another project. It's
the patient monitor.
Patient monitor. We've been showing it in another video. Right now we disassembled it a bit. Like,
oh, it's still okay, just doesn't have the old enclosure, which is yellow and wasn't much of an enclosure.
So we've been doing like tests of stuff for it. Like this white stuff is supposed to be the front part of its.
We actually found out that we can't fit the enclosure or even any part of it on our build plate, because it
flex 2 millimeters.
Yeah, the screen is like exactly the size of it. So we were trying to
design around it, I guess.
And we still didn't do it, but we were working on it, I guess.
Yeah, and maybe turn this back to the guys. I just showed all of our, I don't know, what we have here. We're basically elbows deep in production and buying supplies. We love buying supplies, me in particular. Okay, so we just give work back to.
You are right, oximeter is on our side. Here it is.
Oh, hi, oximeter. We've missed you.
No.
Yeah, it's the first iteration, but still.
Still alive.
The new one is a bit like thicker, but less long. I don't know. I think we can make it. I think we can make it smaller though, because.
Definitely, we really can make it. Well, actually, we can make it much smaller. We just on this version we specifically tried to use is relatively easily available module with any ref and all stuff inside, and it's very large. Also, we use the large chip for ADC. Don't have to do that. We try to make it easy to assemble by other people. And probably it is, but it is too large still for convenient use. So we want to make it smaller.
Yeah, we've been investigating the different commercial oximeters so far, and they're pretty similar. And really, basically, ear oximeter is a thing. What you've been proposing about ear oximeter, they do oximeter on ear, but they're large. I think we can make it much smaller. People don't use it much because they're bulky, and it's not very convenient for people to use in hospital. It's pretty annoying for them. But I guess if they're not bulky, it won't be annoying.
I guess there is some story behind why we're doing an oximeter now if we were so deep into other sensors. Well, it's because when COVID hit in March and we were like quarantined and our order of yield boards like went through the roof, or the other way around, we thought we should do something with the pandemic, and this was really the first thing we thought of. The second thing we thought of was the pulse oximeter, and back then everyone was doing either ventilators or oxygen concentrators. Dmitry actually made an oxygen concentrator board for a different project, not our project, so we don't really mention it. But then we like stopped working on the oximeter, and then we started selling uECGs. But we really want to get back into it because the pandemic isn't going anywhere. Like,
Yeah.
really doesn't. So the same with the patient monitor. We actually wanted to get some funding and produce them, at least several prototypes for use here in Ukraine. But then like nobody cared, and right now.
Yeah, there's a lot of barriers, and there's a whole topic in itself, and we don't have much time left.
Yeah.
So we could talk about barriers like for an hour, like FGA and how we don't like FGA and that it exists. But I'll just give word back to Dmitry. They've been really doing some nice stuff there. Yeah. And so from what I see, actually, Olga has been doing some nice stuff there. And I think that the point is, if you track these movements, you could teach people or like repeat these motions by robotic arm.
Yep.
Actually, yeah. We could just make our arm do it. Oh. Yeah, we've been slapping ECGs everywhere because uEMG is not yet ready, so. But I guess they look futuristic, so there's a lot of LEDs.
Maybe you talk about your devices, about
this concept as a
concept.
Maybe you will talk about your devices as a concept.
Oh, please do. Please do.
Yeah, well, we had an idea back in 2019 where we were still doing various uECG versions, that we could make our devices work in the same ecosystem, as they say. So they would exchange data together, and it would be processed, and people could view it. And for that reason, we called them uDevices. And our original idea had the uECG, the uEMG, well, the uEMG is here, and the uGlass, which was a augmented reality module for any eyeglasses. And Dmitry and Olga have it on their side, and maybe they can show us if they can, if it's not lost somewhere.
Lost somewhere.
Okay. Okay.
Yeah, they've been moving recently, so I guess they lost some stuff.
Yeah.
Really. Well, I probably should show you another part of our room, not intended for streaming, which represent our state of things. So yeah, it is somewhere. It is, but
yeah, we made that part of our room go into boxes.
Yeah, it was kind of like that. I mean, our room never looked so clean in a year or two. Like 2 years, I guess. Yeah.
Yeah, there was a lot of stuff on bed. Like there were components all over the bed because we really need to do some like what do we call it? Inventorization.
Yeah. Fuck.
I guess for Russians watching us, it's inventorization. For Ukrainians, for like Russian speaking audience.
If anybody's speaking Russian watching us, yeah. But anyway, I think we should wrap up very soon. But about the, I just wanted to finish with the uDevices. Like the original idea, and we could show you if we had the uGlass, that it didn't quite work because we didn't have time. We were doing it for the last year's Maker Faire Rome, and we didn't have time like as usual. And then in 2020, there was the pandemic, and we added the oximeter and the patient monitor to our uDevices family. But there's not actually a family right now. There's mostly prototypes in the uECG, but really things have been looking up, and we've been selling uECGs, and we've mostly resolved most of our problems that we had, the backlog of them from back in 2019, like not having any money. And with that, and we have the new printer, and with that, we are ready to start doing the rest of the devices.
Yeah, there is a family of devices. Legit, there is like 6 devices, and 3 of them are beyond the first version, certainly. So I guess.
Yeah.
But also the idea about these devices is that if you connect them all, like how do you use them in an ecosystem? You put on glasses, and you, for example, can see how is your patient feeling, or how someone wearing an oximeter is feeling. You don't maybe actually need the vital signs monitor anymore if you have a uGlass. You can see it on your glasses. That's a new media that people can use for seeing stuff instead of screens. So and right now they're inaccessible, like really though. They're very closed and they're very bulky. So when we thought of a module back a year ago, we really think we should continue with this module because people can just put it on usual glasses and it will be just light and they will see all of the other stuff there.
And they would
not
feed.
only from the smartphone, yes, and it would feed. So that's the idea.
It's basically the whole idea, I think, behind our devices was to make them open source and cheap and available. And this was the idea with the patient monitor too, because they were hugely expensive and there wasn't any. So that's basically what we were doing. That's basically why we were doing stuff, to make it open and more accessible.
Yeah, because it's annoying.
Yeah.
Not only annoying, but it's like, this shouldn't be like this. Did you find something to show? I think they want to show us something. Yeah.
Yeah.
What?
Please show stuff that you want to show.
I won't say that all what we doing and show you it's open source, open hardware devices, and we write about them many things and files on Hackaday, and we have our project on Make project platform, and at the end of our stream, Dmitry will play some music for all people, all 12 people that watching us. I put camera on other side.
I like their table though.
Yeah, it's very nice.
Please show my hands. Yep. Can you see? Can you hear?
Yeah.
Okay. Well, I don't know, maybe I'm trying to understand if it's seen well enough. Yeah. Okay, so you will be able to see how sensors are activating together with fingers and.
Wow.
Wow, yeah. One thing though, maybe we should decrease the sound a bit because I think it's very loud.
Maybe I remove a bit camera from the piano.
Yeah,
just make it a bit further.
I will do it.
Thanks.
Okay, yeah, that should be better, I think. Wait.
Woohoo!
Okay, that's it.
Hop.
Okay.
I hope it was not too bad.
It wasn't bad. The sound was disappearing. It was really a pity because sometimes the mic on the phone, it just dropped the sound, like dropped some frequencies. And we couldn't hear the music like third of the time, like a third of the music,
Well,
like some frequencies.
I hope that it's better on the recording, to be honest.
Well, we will make a recording showing that in a better
Yeah,
quality.
maybe it's just a phone also. Maybe.
Yeah,
But it was really cool looking because of the lights.
yeah, like very cool.
Thanks.
Yeah, thanks.
So I guess that's it. We kind of have some time left, but not a lot of it. I think we should wrap up.
Yeah.
Yeah.
And
Okay.
yeah,
Thanks everyone for watching.
Thanks.
if anybody has any questions, I guess there will be a Q&A session after this.
Yeah.
On last 2 minutes.
Yeah,
No, we don't talk Espanol.
Oh.
oh, yeah, sorry.
No, that's
Okay,
maybe all.
that's it. Bye.
Bye, bye.
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 How do we stop this thing?
There is a Q&A button. No open questions. Okay.